I'll go ahead and get started here. I'm going to minimize the control panel on my end, and we'll get started. So, the subject of today's webinar is simplifying the most complicated of parts with Mastercam 2017. And if you weren't already aware, Mastercam has released Mastercam 2017. That's the newest version of Mastercam. It's been out for about a month. And for all of you that are on your current maintenance with us, now that new version is part of what you get. And I highly encourage you to go and download it, get it installed, and start working with it. So, like I say, the subject is programmed for complex parts, and I've got a couple of parts I'll show you, but the first one I'd like to focus on is this downhole bit that we programmed and had running at the OTC Show in MLC Cassison's booth. The big thing this year was to showcase, the two methods of manufacturing, additive and subtractive. Obviously, Mastercam is a subtractive method. You're starting with a larger piece of material and carving it away to form a part. And in our booth, Champions Machine Tools of Houston had brought in one of their brand new state-of-the-art 5-axis Haas machines. It's a UMC 750 Super Speed. And it was just letting us prove the point that not only can Mastercam program the toolpaths, but here's the machine running it. And then at the opposite end of the booth, MLC had a 3D printing setup, machine, that can print this part from nothing. And we actually had the same bit there on display that had been 3D printed in metal, which I think was pretty cool, printed in titanium at that. So, the thing we're highlighting today is the subtractive methods with Mastercam and showing the new features that 2017 has to really help you succeed in your complex projects. So on this bit, at first when we started programming it, a complex piece like this, it's always a given that there's going to be some tweaks to make and things like that. And the cutting time on it was around 6 hours to begin with, and just to show that in a trade show, people will lose interest really quick. So by using Mastercam's newest toolpaths, that let us get it down to less than an hour. Very, very cool. And it was done in the Mastercam 2017 interface. It wasn't done in the previous version of Mastercam. It was done in 2017, for the purposes of highlighting what's new. So, the way we did that was using Mastercam's new multi-axis roughing toolpath. It's a roughing toolpath intended for the multi-axis environment. And it lets you use basically one of two different methods to rough it out. One method is using the offsetting method. A good way to describe that is by using like the old style of pocketing, like you would use in older Mastercam toolpaths, where it lets you step down a little bit at a time while you take a wide radial step over. The thing we showcased in our booth was the dynamic toolpath. Mastercam does have dynamic toolpaths in the 5-axis environment, which I don't know how many of you all were aware of that, but the same kind of features and benefits you enjoy with dynamic machining in 2D high speed, or in the 3D high speed toolpath by using OptiRough. The 5-axis environment has it as well, which is really cool. And I'll get into showing this bit in detail on how you can work with these kinds of things. But the thing about the multi-axis roughing toolpath is it makes it very easily switchable between machining styles. And all of us have been there. You've got this one job you're machining, and it's just not going at all the way you planned, or you're having issues, and you need to switch strategy. So switching that strategy could mean a lot of time spent in reprogramming, and what I want to show you is how it's very easy to avoid all of that with this new toolpath. The thing that the guys that are watching the bottom line really enjoy is the machine time reduction. Just the cycle time. The quicker you can get it cut, the sooner you can get it shipped. The more volume you can run through that machine. Not only that, but at the same time, believe it or not, it's actually optimizing the cutting tool life. These cutting tools are expendable items, and the more efficiently that you can use them, the longer they last. The less money then ends up costing you to make the part. Other things that really matter is removing air cuts. Anytime the tool is cutting air, and sometimes it's kind of an unavoidable thing. I'm going to show you how you can trim away those air cuts so that any time spent in cutting motion, it's always cutting material away. It's not cutting through the air, wasting time. And above all, I just really want to demonstrate how easy it is to program. I know a lot of guys, when they're looking at getting the 5-axis, it's just it's like this big hurdle, it seems, is that there's going to be a lot of new things to learn. There's never enough time to learn it. And the way I like to present it is that Mastercam, it really just requires a minimal of inputs from the user, and the idea is to let Mastercam do that thinking for you. So I'm going to show you a little bit of that. I'm also going to show you how we can do dynamic motion technology in the lathe environment. And if you notice on this lathe part, you can see I've got it positioned that a chuck is holding at one end, we've got a tail chuck on the other, so we've got a firm setup on it. Rather than taking these constant depth cuts using traditional lathe toolpaths, Mastercam has a dynamic roughing toolpath for lathe, which is really cool. If you've ever dealt with machining on the harder alloys or hardened steel, where it tends to wear out the cutting insert, and you're constantly having to keep a watch on it for chipped edges. This toolpath, it lets you take advantage of today's modern tooling, such as ceramics. The ceramic inserts, they're made for just running at super high feeds and speeds. Only catch is that they're very fragile, and it's very important that they're run in a manner that works with the physics they're working against rather than working against the physics. What I mean is like taking constant depth cuts. You start notching the insert, and once you got that notch started, it just kind of goes downhill from there as the insert starts to erode away, and before you know it, it's going to break on you. This toolpath lets you take better advantage of those things. But that's kind of an overview of what we'll be going over in this webinar. And with that being said, I'm ready to get into the goodies and showing what we've got in Mastercam. So first thing I'm going to do is go directly to our machine simulation. This machine simulation is showing exactly what was run at that show. As you can see, we've got the Haas UMC 750 machine. And if you weren't already aware of Mastercam, any level of mill, it already has machine simulation built into it already. Any level, with the exception of the basic mill entry software. But for Mastercam Mill and Mastercam Mill 3D, with Multiaxis included, all this you can get with it. The machine housing, it gives you controls for how you can make the part more visible. You can turn off the visibility of the housing just so you can zoom in right to what's important, what's being done. You can bring it back as needed, and it makes a really cool display tool. For if you need to give a presentation to a customer at your facility. I see a lot of facilities, they have the TV screens in the lobby, showing a video on loop of things going on in the facility, to give your prospects, to give your customers kind of a cool visual of what it is that you do with your business. On this machine simulation, it really helps out for presenting a cool image. But I want to show this part running, and you notice that what's happening here is it's going in here and it's taking those dynamic passes on it, and it's doing that in 5-axis motion. Right now, obviously, it's just 4-axis working at any given time, but as that tool begins to go on and on, gets closer to the end, to where it starts rounding over, that's where it starts getting really cool. And something that's really important when you're taking roughing cuts, anytime you're rough cutting material, it's important to maintain a constant depth of cut relative to your tool tip. And you see that that's what this toolpath allows it to do, because even though all 5 axes are dancing around like that, if I go and put this machine into a tool focus, you see what's happening there at the tool. It's maintaining a constant depth of cut, and what that's doing, it's keeping things from occurring like having your tool plunge on you, things that would really cause a nasty problem at the machine. And what that's doing is giving you the assurance that you're not going to send a toolpath to the machine that's going to break your tool. You know, I don't like working on a job that's not reliable. I like to program toolpath such that I can get it running and I can have the confidence. I can walk away, you know, have my optional stop enabled if I want, just so it stops before it goes to the next, but have the confidence that it's going to run it in a manner that it can be, you know, easily run, you know, within. So having shown you this, I'd like to show you how we set this toolpath up. So I'm going to go to Mastercam 2017, and that's where I'm at now. If you haven't seen Mastercam 2017, you know, I highly recommend you come out to our rollout events coming up soon. But you know, this is a new interface, and you can see that on our toolpaths tab, you know, we've gone to a tab interface, or you know, like a ribbon interface they call it. And we go to toolpath, you have galleries of toolpath options. Like here's our multi-axis gallery. Here's our 3D toolpath gallery, and then, you know, last but not least is the 2D gallery. But you know, I'm not focusing on that stuff. I'm focusing on the cool 5-axis aspect of it today. So I'd like to show you, you know, how we can go about creating a 5-axis toolpath to cut this out. Now, anytime you do a part like this, it's always going to involve some degree of geometry creation. You know, the customer of yours who has contracted to you for machining, you know, those guys don't understand what's needed for you to do your job. You know, that's what you guys know what you can do. So using Mastercam geometry creation tools, I've gone ahead and created some surfaces and boundaries to kind of bound in these regions. So you can see that when I turn on my levels for level number 8, you know, I've got just simplified surfaces that just create these zones to machine within. And notice that I've got some overlap here. You know, this is kind of a trick of 5-axis machining that we train you in. You know, if you come to train with us at MLC for 5-axis, is to keep your inputs really simple. You know, the simpler you create the inputs, the easier it is for you to get what you're looking for, as well as, you know, it really simplifies the processing that your PC is having to go through to do it. But let's take a look at how we create a toolpath. Let's start off, say, in this zone that we've got right here within that. So the way we do this, I'm just going to turn off the actual bit itself for now, just we're looking at only these surfaces. When I go to my multi-axis toolpath gallery, you know, it's right here. We have our roughing or 5-axis roughing toolpath. So we choose this, and then it'll come up with our toolpath dialog and all the settings we need to give it. I'm just going to kind of shrink this down a little bit just so we can see a little more easily. Well, I guess it's already as small as it can go. You know, just a little bit about this part. You know, this part was scaled considerably down for the show, just so we didn't have such a huge part and you know, work holding challenges. You know, it's actually scaled down to about 4 inches in diameter. And I was using this 1/4-inch 2-flute carbide bull end mill to run it. That's another trick is, you know, anytime you're roughing, it's always good to use something that has something of a corner radius. You know, not a sharp end mill. The corner radius holds up better for you. But when we go to set up how this stock is going to be done, it's actually very simple. When I go to my cutting pattern, I just need to tell it some floor surfaces, and I need to tell it some wall and check surfaces. So the floor surface, that's obviously going to be this guy right here, and I'm only doing one vein of this drill bit for now, or one flute, we'll call it. And then we'll end that selection. Our floor surfaces are selected now. Next, we need to go and pick what defines our wall and our check surfaces. So that's easy. We'll just go through and pick the surfaces that enclose that region. And we'll end that selection. Now, obviously, the flute, it's open at the top end, and I want my cutting tool to enter from there. I don't want it trying to drop in the middle of material. I want it to enter from the outside and work its way in. So, you know, that's where I need to give a 3D containment sketch, and I've already got that sketch created. But you know, what we do is go and select it, and it's just using, you know, typical Mastercam, you know, chaining, you know, techniques. Basically, just picking a boundary that encloses that. And notice I do have that boundary drawn way down underneath, just so that it's given plenty of room to enter. So once we've gotten that selected, you know, a few other things we can set is, you know, the depth of cut where we're going with the tool. You know, on this cutting tool, it had a 1/2 inch of flute. So, you know, if it has a 1/2 inch of fluid, I like to cut about 1/8 of an inch less than that, just so I'm not right at the limit of what the tool can handle. And then I need to give it a maximum step over. You know, this is the radial step over the tool is taking. You know, so basically you have the depth step you're taking and the radial step. And you notice that as I click in these fields, it gives you a nice image up here to help kind of clue you in on what kind of data is you're telling it here. So that, you know, I've gotten that part selected. The next thing I need to do is tell it where the material actually exists to be cut. Because if I leave it as it is, it's going to interpret that zone I have underneath the part as material to machine, and you know, obviously that's all air now. So the way we control for that is we go to our stocks tab, and we can tell it that our stock is based off of, you know, a number of things. You can base off wherever you define in your job setup, you know, off of a stock model, or I can go and click a solid body. So I'm going to go and select for a solid body, and I've got a level created where I've got some, you know, like these pie section pieces of the part. Basically, you know, that section I selected, you know, it only encompasses where I'm making the cut. You know, that's another trick, you know, is in keeping your inputs really simple. I mean, I could go and select the entire revolved body, but it's going to process that cut against everything on that body. And all that really matters is right in the zone, right? So if you create a partial section of it, that really helps out on the processing time. So I'll go in and click End Selection, and say we're done at that. Let me just make sure we got that again. Let me remove that. I'll go and reselect the stock body. We'll end that. Say Done, and now we're done with that. We can go ahead and click the green check. And the toolpath is now, you know, processing. It's going to work and creating what we need to do to cut it. So I'm going to toggle back to my toolpaths tab, and this is the toolpath we just created from that. And I'm going to have it display, you know that, and, you know, and that's it. I mean, you saw how easy that was. I hope from that it is able to derive all that toolpath motion, and you know that's all there is to it. It's really very easy, and you know, in my opinion, it's almost kind of easier to create one of these advanced toolpaths in Mastercam versus using you know, just like wireframe and 2D methods. You know, on those, you know, nothing against them, but you're having to give it a lot of inputs. You're not only picking the boundary you're cutting to, but you're telling it, you know, which side of the boundary or the chain that you're cutting on. You know, how deep you're going to. You know, things you're having to avoid. And with this, I'm just basing it off of the model itself. I'm just giving it a few simple inputs, and Mastercam does the work for me. You can see that once I've gotten that toolpath made, I can go and set. First off, I'll go in and tell it, you know, what I'm using for my stock. And for my stock, I've got a solid body that's on level number 12. So I'll select that as my stock for what I'm about to do in my verify, and we can go to verify, or if you want to call it toolpath simulation. You know, if you've been using Mastercam since version X7, and then obviously you're familiar with the new, you know, the Mastercam toolpath simulation interface. You know, this runs within its own window, so I can run it completely independent of Mastercam. If you have a computer system at your place of work that has more than one screen, these kinds of things you can space across multiple screens, you know, multiple displays, and it just gives you a chance to see what it is that you've got going on. But what's really cool here is if you look at it, the total time for machining this one toolpath is 8 minutes, and you know that was all really simple to put together. You know, if I'm programming at a real job like you guys are, you know, see, I'm just selling the supporting software, but you guys are actually using this. I look at this and I think, wow, you know, that would make my job so much easier. Plus, whenever all your colleagues see what you program their machine to do, and they see it dancing around like this, I mean, you know, it's just think about the mad props you're going to get. And keep in mind that part of the service you get with MLC is technical support and options to talk with us on training. You know, there's no denying. I mean, these kinds of toolpaths, even though I show you how simple it is in the end result, I mean, obviously you're going to need some help and some training to get there, and we can help you succeed with that. And then where the rubber always meets the road, it's like, yeah, we've got something running that looks really pretty. Well, how do we get it to the machine? Well, from there we just go through and post-process it. Run through a post-processor, it's going to convert it to the code that's specific to that machine. And this, by the way, is where you would have your machine definition already pre-selected. Now, in this case, it's a UMC 750 machine that we ran at the show, and you can tell by how long it's taking to post. There's a lot of math happening here. I would not even want to think about trying to write this code manually. That's what you got Mastercam for. And you just load it onto a thumb drive or send it through the network to the machine, set it up, you're ready to go. So a lot of goodies with that. So now we've gotten that one toolpath done, I'd like to kind of just pretend we have a scenario here. Let's say that we started running this job, and it's breaking our tools left and right. Even though we're using dynamic motion technology, maybe there's a lot of tool pressure on the tool, and it just won't hold up. It keeps breaking. So that's where I would usually call in a sales rep for like a cutting tool. Let's say ISCAR, for instance. I know ISCAR has been a big help to me in my past, among other suppliers. And let's say they say, oh, I've got the tool you need to run on this. It's this new high feed mill. So you're going to need to change your tool path from this dynamic approach to taking light depth passes of only 20 thousandths per pass. Say we need to step over 150 thousandths per pass at a time, and you think, well, okay, well, I need to reprogram a toolpath now. And that's usually where, on a complex job like this, you're thinking, oh no, how long is this going to take to reconfigure this for a depth cutting approach? Well, see, all you have to do is just edit that toolpath you just made. It's as simple as that. You can see right now we're using the dynamic cutting strategy. We're going to change it to an offset method. So how we do that, we go back to our parameters, and we go to our cut pattern. It's where we selected for our floor surfaces and our wall surfaces. Down here for the pattern type, it's set to dynamic. We just simply change it to offset method. Once we've gotten that, a few other things, we know we need to take, as was recommended, only 20 thousandths per pass and a maximum step over of, I say it was 150 thousandths. So we've gotten that. Obviously we probably need to go and adjust our feed and speed. That's easy stuff. And then we just click OK, and then we tell it to regenerate, to rebuild that toolpath. So you're just letting it do the work for you. So we sit here and let it do its thing. Sometimes it can take a while to process, depending on how complex a project it is. At the time you can go and get your coffee. You can go and go and talk to the guys on the floor, see how their weekend was. You're letting the computer do the work. You're not having to do a massive reconfiguration of things. You're letting it do it for you. And as you can see, it's already done. And now it's ready to go. Now, I noticed, one thing you may be noticing is all these lines up above, they're all in blue. That's all feed motion. And to kind of give you an idea of why that's feed and that's not rapid, is because it's making several little moves, one endpoint to the next. And if you're in rapid motion, in this case it's on a Haas, all 5 axes, as they arrive at the destination they're commanded to go to at their maximum feed rate. So it's making, trying to describe it like a dog leg move. And I know you all have seen it. You've got that machine that when it has a rapid traverse, diagonally from one point to another, instead of just going straight to it, it kind of does a 45 and then a straight line the rest of the way. By converting this to feed motion, it really smooths the machine out, and it's actually very easy to do. That's one of the controls you get with these multi-axis toolpaths. I'll show you where you find that. If you go to the utility tab for your feed rate control, what we've got here is just to use a rapid feed rate of, we just gave it 399 inches a minute. Of course, if you uncheck that, it's going to be in true rapid, G0. And you can always tell by when you regenerate it, it always represents the rapid moves as yellow, and the feed moves will be blue. So, it's all very easily switchable within here, and depending on the make and model of machine you're on, it may be just fine to run it like this. But in some cases, if it makes those dogleg moves, just be aware that it's very easy to smooth all that out by just converting all the rapid moves to a rapid feed rate instead. So, that being done, at that point now is where you can go ahead and post-process. Go to the machine, take your new cutting tool you got from your tooling rep, and you're ready to run. It just makes it really painless on you. Before I came to MLC, I came from a background of 5-axis, and there's a lot of complexity in that, and a lot of things we had to go and kind of work with. But anything I could do to make the computer do the work for me, it was always just a huge help. It just really helped me get the job done quicker and easier. The part got shipped. That always made the boss happy. When it gets shipped, it gets sent an invoice and we get paid. Anything like this that you may have questions on, just keep in mind that you can speak with us here at MLC. You can contact our support or contact any one of us salespeople directly. All of us guys would be happy to speak with you on what Mastercam can do in these advanced applications to help you out. So now I've talked about some rough milling on this. Talk about some other cool things like how we go about drilling all these little holes. And in case you haven't seen one of these downhole bits, what happens is these holes, after the bit is machined, the manufacturer brazes in these little carbide or not carbide, but these like they call it PCD, these polycrystalline diamond cutting edges. Because this thing is drilling through rock and the earth, so it has to be really hard. Only thing is, the machinist has to drill these holes, and not a single hole is parallel to another on here. Every hole is at its own unique angle, and by using conventional drilling means, that would mean you would have to create a working coordinate system or a tool plane that's relative to each hole, and then you create one drill operation to make a new plane, another drill operation, another plane, and so on, and it'd be very time consuming. The thing I want to point out is that Mastercam has a 5-axis drilling utility that really makes this a lot easier on you, and that can be found up here within your multi-axis gallery, right here as your drilling operation. But before I create that toolpath, I need to create some geometry to help me drive this. And that geometry, I need to basically have a point and a line for each single hole on here. The point is going to represent the bottom of the hole, and the line is going to represent the vector that the drill needs to drill along to get to that point. Basically, that line determines the angle the machine has to go to. And Mastercam, underneath the model prep group, has a cool utility for doing just that. It's by using a hole axis or creating a hole axis. So when I go to select a hole axis, it's asking me for some things here, but basically if I hold down my control key and I just select any one of these holes, it will, from that, it's able to go and find all holes of the matching diameter to put along with it. Let me just show that again real quickly. Bring the bit back within view here. Apologize for that. We'll go ahead and do this again. You just choose a hole axis and you control select one of the holes, and you can see that from that, it highlights all holes of matching diameters. It's already creating some geometry, and this should be kind of I know the first time I saw this, it just really it just sent the gears turning in my head. I could think of so many ways I could use this to simplify things I had been doing. But over here you have some options for what geometry to create. If you want to create circles on it, you can, but that's really not necessary for this operation. And for my points, I can create a point at the top of the hole or at the bottom. And if you notice, that feature, recognize that those holes are blind features. So, from the bottom in, it recognizes which way is up. So once we've gotten that selected, that's all we need when we click the green check. And that geometry is now on the screen, and next we're ready to look at drilling these holes out. So now we're jump back to our toolpaths group, and we're ready to go and select our drilling operation. And you want to be sure and select under under multi-axis drill, it's not the drill operation see over here under 2D. What we're doing is using an automated 5-axis drilling utility. So we select that, and first thing you may notice, especially if you're familiar with regular drill, is that this toolpath, it hasn't even asked me yet for what holes I'm drilling. It just jumps immediately into the settings, so or the parameters, we'll call it. I was using a 3/16 two-flute carbide end mill for this, but ISCAR, for example, they make a specific cutting tool just for drilling these holes. Drilling it in one shot. Holding a tolerance of +2 - nothing. It's if you haven't checked out like the unique application tools they've got, I highly encourage you to do so. But what we'll do is choose that tool. You can give it a feed and speed. And then we go to our cutting pattern, and this is where we select not only what geometry we're drilling, but what kind of drill cycle it is that we're using here. Now, for the geometry selection, it gives you a variety of things. You can select just points only, or points and lines, like we're about to do here in a minute, or just lines only, or features. Features, that'd be like if you have a solid model that you had a specific solid feature, like let's say we have a solid extrude operation that's driving some stuff. We can just go click that, simply click that solid feature in the tree, or choose from the model, and that would give you the geometry the toolpath needs. If you're selecting only points, that would be, if you can imagine like an aircraft wing, just drilling the rivet holes all along the surface. Basically, you're just drilling a perpendicular hole at the surface at any given point, and that angle, of course, is going to change depending on where you're at on the wing. But in our case, we have points and lines, so I'm going to select that as my method, and I need to go and pick some geometry. So this is why I like this toolpath, because they just make it so easy. I've got point geometry here, right? So I can just do a window of all my points. I'll just pull a window around the entire part model, and it says, okay, select the starting point. I'm going to turn the model transparent just so we can see through it here. I'm going to start with that point. And notice it finds its way from one hole to the next. It just makes it so easy. It's like picking an array of holes in a 2D fashion, but now we're doing it in 5-axis instead. So we'll go and click our green check, and we can go and establish some cut parameters. So we'll just do just a standard drill, a G81 drill cycle. For our tool axis control, obviously we're going to be outputting in 5-axis, but do notice that you can output in 4-axis mode. If you've got a 4-axis mill and you're working on parts that have all kinds of holes drilled around a part at several different indexes, and sometimes they're on center line, sometimes they're not. This toolpath can really help you out with automating that. And of course, 3-axis. If you want to hold the drill at some given angle, you have that as well. But obviously we're doing this in 5-axis. Next thing is on our collision control. This is where you can control for the tip compensation of the drill. So if there is a tip to it, you can have it compensate, add for the shoulder on it. Or if you need to add a breakthrough, it'd be like if these parts, if you're going to pre-drill it and then come back and then circle mill it after the fact, then this lets you compensate for it. I'm just going to have it go to the original, or the projected point you've already selected. I'm going to turn this off, and then for our linking tab, this just looks really similar to how a regular drilling operation is that you're probably already used to. This is where you can figure for the top of stock of it, the feed plane, the depth that you're machining to. And what's really cool is if you have several holes there at the same diameter, but the depth of them varies from one to the next, which that kind of is the case on this part. Some lines are longer than others. It's just representative of how deep that particular hole was. It can figure that top of stock automatically just based off the line length, which I think that's a great feature. I mean, it keeps you from having to go and find for yourself which line is longest and then try to set it off that. So not only that, but air cutting. That's a big thing we talk about is eliminating air passes on these kinds of tool paths. So we just go and click the green check, and we let Mastercam do the work for us. And once it's done, with one tool path, mind you, one tool path that takes care of drilling all these holes, not one tool path per hole. I just think this is so cool. You know, I've always gravitated towards the more challenging projects, and I tell you, through the years I've been using Mastercam, you know, so much has been done to this product, the Multiaxis product, that it makes these kind of projects that used to seem really, you know, intimidating, or they look almost like something that you'd rather not quote. It's giving you tools. You can bring this highly lucrative work into your shop and run it with ease. And us here at MLC CAD Systems, you know, we have the resources you need to rely on to be successful with this. So, you know, after this webinar is over, if you'd like to speak further with us, you know, by all means, please contact us. You can either contact us at our Mastercam sales line or at our Mastercam support line. You know, either one, or you can just contact your salesperson directly. But yeah, MLC really encourages you guys to grow with your software and grow your capabilities. And I can tell you with confidence that what this gives you, I don't even have time to show you everything. It really gives you many tools that you may not be aware of. So I just want to make sure everybody's still with me, make sure people aren't checking their emails or have got me on mute or this and that. So I want to test you. I saw one hand, Todd Brown. If you can raise your hand for me again, I'd appreciate it. I just want to make sure I've got you all still with me. I'm watching the dashboard here, and I'm seeing hands go up. Good deal. I hope everybody's enjoying this so far. I'm about to show some Mastercam lathe, you know, some dynamic motion technology in Mastercam lathe. So I know that with the machining, you've got mill guys and you got lathe guys. It's not real often that you have guys that are equally on both, you know. So I don't want the lathe guys to feel left out. There's a lot of really cool stuff to show you in lathe. So I'm going to go ahead and put the hands down. I'm going to jump into the lathe side of things. And not only is it Mastercam lathe, I'm showing you Mastercam lathe inside of the integrated SolidWorks product. That's another thing. I don't know how many of you all may be aware of this, but if you're using both products, if you're using Mastercam and you're using SolidWorks, and your subscription and maintenance is current on both, Mastercam allows for you to run Mastercam embedded inside of SolidWorks at no extra charge. You know, that's not something you have to buy. That's part of the licensing that you already have, you know, with current maintenance. And the way this works is, you can see I've got SolidWorks open, and when you have Mastercam loaded within SolidWorks, it adds a tab to the Command Manager at the top of your screen, has all your toolpaths laid out, and notice it's laid out in SolidWorks format. Yeah, you go to your SolidWorks Features tab, things like your extrudes and your revolves, your sketch tab, all your sketching tools. Well, you've got Mastercam in here, and you know, you're basically using SolidWorks as the CAD interface with Mastercam running inside of it. And what's cool with them being all one and the same, you have full associativity, you know, all the way from your design side all the way to your machine tool. Now, if any kind of design change occurs to the SolidWorks model after you've already created toolpaths, those toolpaths you created, they remain associated to the geometry in SolidWorks, so if that geometry changes, and your toolpaths update with it. You know, very cool stuff. But here in lathe, you know, what I've gotten here so far, I'll just play this, you know, from the beginning here. Show you in our toolpath simulation. I have a lathe part's a large diameter blank, and I need to do some roughing on it, and I obviously want to have a tailstock on it, you know, to put a center to support that end out there before I get to roughing it out. I'm just going to set my stock condition of operation change. You know, I click play. First thing I'm doing is facing it, running really slowly. Then I go in and spot drill or center drill, you know, to give the tailstock a center, and then we bring our tailstock in. Now I can finally get down to business, and we begin roughing it out. So by using the conventional, you know, Mastercam roughing toolpaths, you know, we're just taking constant depth cuts. You know, this is typical of how you would run a roughing cycle on the lathe. And you know, to me, I always thought this stuff was cool. I always loved watching just a lot of metal getting cut away. But the only thing against it is, you know, it does add some time, and you can see that just that roughing cycle alone, we're at almost half an hour based off of our current parameters. And we can use Mastercam's dynamic motion technology to drastically increase that. And that's what I'm getting ready to show you is how we increase that with Mastercam's dynamic roughing toolpath for lathe. So going back to Mastercam now, we're going to talk about how this works. I'm going to place my arrow right just above that roughing toolpath. Just so, if you haven't already used Mastercam lathe toolpaths are very stock aware. They're basically aware of what stock is already existing for it to cut. So I need this toolpath to see all this remaining stock above it for this to work. But when we go to our lathe group, we have our dynamic roughing toolpath, and this is what we'll choose. So now we're going to pick our chain, and this is where the chaining in SolidWorks, it differs from that of Mastercam standalone, because obviously we're using SolidWorks as our CAD interface. But I think you'll really like what you see with this, because what I can do is just go and select the entire solid body of the part. I'm not having to walk it from one to the next. I can go in and tell it that I want it to replicate a spin profile of it. And when I go to my change tab, using those selections, this is the chain that has been derived of it. It's like an automated spin profile. In Mastercam standalone, you can go and create the turn profile of a part. Well, with this, it's able to figure that internally. Now, I've got the chuck holding it back here, so obviously I don't want to turn all the way back here. So I want to adjust where that endpoint's occurring. And you see here with your start endpoint, you can go in and back it off or advance it forward, things like that. Or you can just go in and pick a point, a specific point on there, like this point right here. That's where I want that chain to end. That's all you have to do to get it to know that zone to work within. And then we just click our green check. Now, that being done, now we're ready to set up our toolpath. And you notice now it looks just like a Mastercam. I mean, this is Mastercam. It's Mastercam inside of SolidWorks. So from here, it's just like what you may already be familiar with. What we're going to be doing is using today's technology with these ceramic inserts for high-speed applications. The faster we can rough that part down, the faster we can move on to finishing it. So I'm going to choose this tool here, and I need to edit this because I need for this tool to have a left-hand bias to it, just so I don't have collisions with the holder. And another thing is with dynamic roughing and lathe, it must use a round insert, not a diamond. It's got to use a round. It's the same as you're maybe familiar with the Mastercam's 2D high-speed toolpaths in mill or 3 or 5 axis mode. It's using that radial profile of the tool to do that what they call trochoidal motion, and the same has to be true here in lathe. So we have to use a round insert. So we're going to go with that. And I start off this part just assuming that we're working with like a 4140. I mean, it's not an impossible material to cut. You can still cut it pretty fast, but you can cut it even faster with ceramics. So where I would be running like a 400 surface foot per minute with carbide, I'm going to run about 1200 surface foot per minute with this. Now I do want to limit that spindle speed. I've got a tailstock on it, so I can let it run up close to the max, and we'll probably never actually get to 3,000 RPMs. But I don't want to speed up so fast that we exceed what the machine can handle. I definitely wouldn't want to be in front of it if it went faster than that. And then our feed rate, because the idea of dynamic machining is you're taking a very light radial pass. You're just moving at a very fast feed rate. And with this, we can probably be running at about 25 thousandths per rev. Remember, we're working with the radial edge of the insert, and that just lets us, take advantage of that strength in the round insert with a higher feed rate. So on our dynamic rough parameters, this is where we go in there and give it the nuts and bolts of what's needed. And this is where, I would highly recommend you work with what your cutting tool manufacturer recommends, but we're going to say run at a radial step over of like 50 thousandths per pass. And this is a roughing toolpath, no doubt, and because we're running so fast and generating so much heat, it could generate a little bit of a hardened edge. So I would like to leave, say like 30 thousandths to come back and machine away with regular carbide after the fact. But you see what's so cool about that? You're saving your carbide, the slower cutting, or only cutting what still remains, not cutting the entire thing. Once we've gotten that done, we can just go ahead and click the green check, and now Mastercam goes to work on you. It's going to generate, quite a bit of code. There's no denying that. This is definitely not a canned cycle. It's when you generate this code for your machine, it's all from one point to the next. But it's running this tool in a manner that you can trust is going to be working within what your machine can handle. Not only that, but it's really optimizing your tool life. So if we go and show this in our simulation here, look at our cutting time. What was it, like a half an hour a minute ago? And we just cut down to a third using this. And click play. Now right away, you saw that red. See what's happening? It's feeding that tool back up the face, and it's bumping the holder. And it's not going to work. So we need to go and fix that. So let's jump back in here. We'll change this up. So when I look at this, what I'd rather that tool be doing is feeding from the back of the part to the front, because that, at least then it can feed its way down the hill. At least while we're feeding down the hill, it's carving out the clearance for the holder behind it. Now when we're feeding up, there's no clearance yet. So what we're going to do about that is go to our geometry, the chain that we'd selected for this part, and I'm just going to turn that chain around to being pointed from back to front, change that compensation side of it as well. Say OK to that. And then we go back to the toolpath itself, and I'm going to change that cutting method to just one way, just so it's only going to cut back to front, not going back and forth like we had just seen. Then I go in and click the green check, let it regenerate. You see I'm just sitting here, hands off the keyboard, just waiting for it to generate the path. I'm not having to draw new geometry. I'm letting this do the work. Only thing is, when I did that, you see that it didn't carry that cut quite over the front edge of the part. It's stopping shy of it. I need this to go all the way past the front. So very easy. All I have to do is go back into here, and I'll use my lead out settings. On my lead out, I can tell it to extend that end of the cut by, the insert's 3/8 diameter, so we'll go by, half of that. That'd be 3/16 of an inch. And we just click the green check. We say OK to that. Let it go. So, very, very easy to go in here and make some changes. Only thing is, it's another thing you run into is that you frequently need to probably check your insert just to make sure you're not wearing it out. To give you a chance to re-index it to a fresh edge. Things where you would have to be at the control and using single block mode, putting it in handle mode, finally jogging it up manually, and then having to restart it. See, Mastercam lets you automate that as well. It's really something you need on these kinds of things by using what we call our tool inspection. This is how you can build in inspection points for you to check that tool and make sure the insert is in good shape. The way we do this is I can tell it to use a user-defined position. I usually go in there and put a diameter of, we'll say, like 10 inches, so it gets it away from the part. Put a Z 1 inch, and we can tell it that I want to check that tool after so much length of cut it's taken. So let's say after it's cut, let's say 100 linear inches, or we can say after so much time in the cut. And you can have more than one position or more than one condition set. The first one that gets met, that's going to be, what it is going to stop at. And of course, you give it an operation comment, so your operators wonder why it stopped. And say check the insert re-index if needed. So it's building these points that your operator is forced to have to check it. It keeps them from trashing a tool on you, and at the same time, it's making it easier on them. So we just simply do a regenerate of this. It goes in and does its work, finds what still remains to be done, and you see all these motions coming up here. That's those tool and inspection points we told to make. When we go and watch this run through our verify, our toolpath simulation, see, I always just highly recommend using these tools because this just gives you a visual way of seeing it before you have any problems at the machine. So you can see it's coming here doing its cutting, and eventually it'll retract. But if you can imagine watching your machine running this, you can just see that the motion it's using. It's almost like I kind of equate it to like running a wood lathe. If you ever run a wood lathe, you have the handheld tools, and you never just take the tool and just jam it in the stock and go straight back. You have to kind of feather your way through it. You go a lot off by feel. It's much easier on the machine, the cutting tool, to feather these areas away rather than just plowing through it. And this toolpath gives you the means of doing so. And then after all this is done, then I know we have some rough stock that still remains to be cut away. Because remember, I left 30 thousandths on it. So to take care of that, wrong one. I'm over here in SolidWorks. Stand by. There we go. So after that toolpath is done, that's where I would then come back with a regular roughing toolpath to finish it. Using, let's say, like a B&MG, or we'll start with the C&MG first. So we'll go in here and do a lathe rough, and I'm going to pick that same solid revolve. Pick the chain we're running, and of course this time we're going front to back. I would go in first off with the our C&MG just to rough the majority of what's there. And what I do here is still set up for rough cutting, but I can tell it to use a remaining stock just so it sees what actually is still there that remains to be cut away. That way we're not wasting our time cutting a bunch of air. To make sure our plunging is, we don't want undercuts with this tool, so we'll turn that off. Click our green check, and now you can see it doing its work. It's just nibbling away that that remaining 30 thousandths that could be a little bit of a work hardened edge from the high speed of ceramic. But you see what you're doing now is you're only roughing away what needs to be roughed away, not doing everything like we were originally. And then of course we can come back with a separate roughing toolpath to nibble away this zone that's in here. But the main thing I've gotten to demonstrate to you today is the power the software has built into it to help make your job a lot easier. So I have a few minutes left here. I'll just kind of wrap things up. In case some of you guys had just come to the webinar a little late, no problem. Just wanted to point out that inside of the control panel on the side of your screen for the GoToWebinar, it has a handouts tab in there, and you notice that it has an item in there. That's our Mastercam rollout dates. It's a PDF file. You can click on it to download it. MLC CAD Systems is getting ready to put on rollout events here starting in a couple of weeks in cities all that are near you guys. Dallas, Austin, Houston, Phoenix, New Mexico, Albuquerque, Lafayette, and I'm sure there's others I'm forgetting here, but that document will tell you where you can expect to see those. It gives you instructions for how to sign up for it. It's a chance for you to come out and see what all is new with Mastercam since the previous release, and not only that, it just gives us a chance to show appreciation to you for being our customers. Come out and have some drinks on us, see a cool presentation at a cool venue. I highly recommend to check it out. But if anyone has any questions about anything you've seen today, anything involving the features that we've talked on, I encourage you to contact us and ask us questions on it. MLC would be glad to help you out and speak with you on what we've had to, the things we had to offer. Things like this Multiaxis roughing toolpath, just making it easy for you to switch between the different styles of cutting. Optimizing your cutting tools and your machine time, and also how to use the dynamic motion technology that's offered to you within the lathe product. All this stuff we can support you on, and be glad to work with you and help you grow with it. So with that being said, I'm going to go ahead and wrap this up. If anyone has any questions, I believe there's there's a field in here for asking questions. You can jump in here and ask a question within that, and then that kind of thing. Now I do see one question in here. Question from, let me make this a little bigger. Can't quite see. A question from Richard Slay. If we're going to have a rollout event near Oklahoma City, that's a good question. Off the top of my head, I'm not sure, but Oklahoma's a big market for us. I'm sure we'll have something that's local, local enough for you guys. So I got that one jotted down. we'll get back to you on that. I have about a couple more minutes here, and you know, if anyone has any other questions, I'll be happy to answer them. Okay, yeah, I'm not seeing any other questions just yet, and we're basically just about the top of the hour anyway. So I'm going to go ahead and close the event out. Once again, I want to thank you all for attending. MLC CAD Systems appreciate your business. We appreciate your time and opportunity to work with you. Any questions at all about anything you've seen today, or if you have any interest in adding on anything you've seen today, please contact us. Someone here at MLC, whether it's myself or any of the other team members, will be happy to work with you. So thank you.